Hello friends, today's question. A particle executes simple harmonic motion between x minus a and x plus a. The time taken for it to go from O to a by 2 is t1 and to go from a by 2 to a is t2. Then we have to find out what will be the relationship between t1 and t2. So we can solve this question by using three different approaches. One is your pure theoretical base, in which we use the basic concept that whenever the object which is executing a simple harmonic motion is near its you can say a mean position, then it has a higher velocity, and as it goes on to its extreme position, the velocity start to decrease. So we can use this part. In the second part and the third part, or second you can say second method and third method, we can use the integration, which gives us exact relationship between t1 and t2. Okay, in the first method we can only identify whether t1 will be greater than t2 or t2 will be greater than t1, or they will be equal. Okay, but in order to find out the exact relationship that t1 is twice of t2 or t2 is twice of t1 or t1 is equal to t2, for that we have to use the method of integration. So they are second and third method in which we are going to use integration, and the first one is understanding the basic thing, how the energy changes when the particle executes the simple harmonic motion about its mean position. So let us first of all explain it based on the first approach. Okay, let us call this first method. So we say, or in the given question itself, it is given that in SHM particle moves faster near the equilibrium position. So near the equilibrium position, and that equilibrium position is represented as O. And to explain this, we can use two analogies. First, we can call it as a energy explanation. So let us first of all explain it based on energy. Energy explanation. So we know that in SHM the entire energy is conserved, and that is a summation of potential energy and kinetic energy. In SHM total energy is conserved, which is given as kinetic energy plus potential energy. And we know that at equilibrium position, we have potential energy will be equal to 0. Potential energy is equal to 0, and kinetic energy is maximum. Kinetic energy is maximum, which means that the particle velocity will be maximum, making particle velocity to be maximum. And we know the expression for the velocity in SHM, velocity of particle in SHM. So you can say velocity of particle in SHM, that is given by v of x is equal to omega square root of a square minus x square, where a is the amplitude, and x is the displacement from the equilibrium. Displacement from equilibrium. So therefore, for the equilibrium position we put x equal to 0. So we can write it at for x equal to 0, that means at equilibrium velocity v naught will be equal to omega a, and this is our maximum velocity. So at equilibrium the velocity is maximum, mean position. Okay. So next is, as the particle moves away towards the extreme position, as the particle moves away towards extreme position, so extreme means x will be equal to either plus minus a. So under this condition the velocity decreases and more and more energy gets stored as a potential energy, and the kinetic energy obviously going to decrease. So under this condition we can say velocity decreases and more energy is, or you can say, get stored at potential energy, and less remains of kinetic energy. And particularly at extreme, you can say at extreme where x is equal to plus minus of a, velocity becomes 0, velocity equal to 0, which basically means its kinetic energy becomes equal to 0. So we have all energy is potential energy. All energy is potential energy, and that will be maximum. Okay, so this is basically, you can say, the change in the potential energy with respect to the variation in the position of the particle. So the kinetic energy is maximum at its mean position, and potential energy is maximum at its extreme position. Okay. So from here one conclusion is important, that as we move away from the mean position the velocity is going to continuously decrease. So as the velocity is going to continuously decrease, the time taken to, you can say, travel the distance is also going to increase. So based on this, as it is said that we have a mean position O, and it moves from O to A by 2 in time t1, and from A by 2 it moves towards A in the time t2. So from here we can easily, you can say, make a conclusion that as we move away from O to A, the time is going to continuously increase. So therefore we can say that our t2 will be greater than t1. So velocity decreases, so time taken to cover the distance is going to increase. So we can say from here that value of t2 is greater than t1. So this is based on your, we can say, discussion based on energy explanation. Same thing can be explained by the force also. So let us explain it by force explanation. So force here means restoring force. Okay. Force explanation means restoring force. So we know that restoring force in case of SHM is proportional to the x. Okay. That is how far it moves away from its mean position. So restoring force in SHM is our F, which equal to minus of kx, and we know that near equilibrium or at point equilibrium x is equal to 0. Let's see, near equilibrium position is O, our x is equal to 0. Therefore the force and acceleration near equilibrium is very small. From here we can say force and acceleration is small. Although the force and acceleration is small near the equilibrium position, but as it is moving from one extreme to another extreme, the particle has gained enough velocity, okay, because of the earlier motion before it reached the equilibrium position. From we can also say here the particle has already gained significant velocity from earlier motion. Significant velocity because of the earlier motion. Because of that, it is going to overshoot the mean position, which usually happens in the pendulum also. And as particle moves toward the extreme position, as particle moves toward extreme position, which means x equal plus minus a. Okay. So as it is going to move towards the extreme position, the restoring force is going to increase, and as the restoring force is going to increase, which slows down the particle, or velocity is going to decrease. So it means that restoring force increases. Restoring force increases. and as restoring force increases, we can say that the particle velocity decreases. Therefore, as it reached the extreme position where x is equal to x plus minus a, the particle stops momentarily before reversing its direction. So therefore, we can say at x is equal to plus minus of a, particle stops momentarily, stops for a moment before reversing its direction. And in SHM, we already know the equation for the you can say displacement, that is x. So we can say that in SHM, position of particle is given as x of t is equal to a sine omega t. Therefore, once again we can say that if this is mean position, this is our a by 2 and this is a. So time taken is t1 and this is t2. So it is going to move towards the extreme position. The restoring force is obviously going to increase, and if the restoring force is going to increase, the velocity is going to decrease, and the velocity is going, if the velocity is going to decrease, the time taken to cover the distance is going to increase. Okay. So in the question it is given that time taken from O to a by 2 is t1 and a by 2 to a is t2. So based on discussion, we can say that our t2 will be greater than t1. So this is based on the entirely the theoretical concept rather, that your t2 is greater than t1. So this broadly covers our, you can see, answer. We can easily identify that option number A is the correct one. But in order to find out the exact relationship between t1 and t2, we have to use the method of integration. Okay. This only tells us whether which time will be greater or which time will be smaller. So we can, from here we can make a conclusion that at least t1 will not be equal to t2, neither t1 will equal to twice of t2, and this B option is also not available. So only option true is our A, that is t1 is less than t2. But in order to find out the exact relationship between t1 and t2, we have to use the integration method. And for integration method, there are two approaches. So next is our integration method. Now for integration method, we say that integration method, let us call it part 1, and we know that velocity in SHM is given as v is equal to omega, and this is our a square minus x square, and the time taken to move from x1 to x2. So we can say time taken to move from x1 position to x2 position, this can be written as t is equal to x1 to x2 dx divided by omega and square root of a square minus x square. Okay. And now we divide it into two parts. In the first part, let me draw the figure once again. So this is our mean position, this is our a by 2 and this is our a. So in the first, this is our time t1 and this is our time t2. Okay. So we are going to do the calculation for t1. So we can say here calculating t1, and t1 is our from mean position, that is 0 to a by 2. So therefore t1 is equal to integration 0 to a by 2, and we get dx divided by omega, and this is a square minus x square. So we are only interested in integration because the omega we can take common. So we can write it here that integration 1 upon a square minus x square and a square root, this gives us sine inverse x by a. So we can write it here as t1 is equal to 1 upon omega, and we get this as upper limit is a by 2 and lower limit is 0. So we substitute it here and we get this as sine inverse a by 2 divided by a minus sine inverse 0 divided by a. So we can write that our t1 will be equal to 1 upon omega, and we get this as sine inverse 1 by 2 minus sine inverse 0, and this gives us that t1 is equal to 1 upon omega multiplied by pi by 6, which gives us pi upon 6 omega. So we got the t1. Now we calculate t2. Calculating t2, and t2 is from a by 2 to a, and so we get t2 limits will be our a by 2 to a, and dx, this is omega a square minus omega square, sorry x square, and this comes as 1 upon omega sine inverse upper limit is a, so this becomes as a by a minus sine inverse upper limit is a by 2 and divided by a. So we can write that our t2 is equal to omega, sorry 1 upon omega and pi by 2 minus pi by 6, so this gives us pi 3 omega. So finding the ratio of t2 by t1, so t2 by t1 is equal to pi by 3 omega divided by pi by 6 omega, and which gives us 2. So from here we get the exact relationship that t2 is equal to twice of t1. Okay, t2 is exactly equal to twice of t1. So from here also we can say that t2 is greater than t1. Okay, t2 is greater than t1. Now second, another method which is also based on integration, and the method of integration in this case we are going to consider limit but in a different way. Okay, so this is our second method of integration. So we already know that the particles start from O to A and A by 2. So this is O, this is A by 2 and A. this is t1 and this is t2, and total time is taken as t. So in this case, we take the limit of integration in both the cases with respect to origin O. Sorry, it is without integration, my mistake. Second method, without integration, sorry, without integration. Let me write it again. Without integration. So we have integration method, and this is only one method, integration method. Okay, I apologize for that. I mistaken said it will be two methods. So in second method, that is without integration, so we are going to use that x is equal to a sine of omega t. This is a basic relationship for SHM, and it is said that at t is equal to t1, the particle is at x is equal to a by 2. So we substitute it here, we get as a by 2, a, and we have sine of omega t1, and a cancels out with a. We get this as sine of omega t1 is equal to 1 by 2, or omega t1 is equal to sine inverse 1 by 2, which comes as pi by 6. From here t1 will be equal to pi by 6 omega. So we found out the t1. Now we use that this total time t is equal to t1 plus t2. It means at t is equal to t1 plus t2, x will be equal to a. Okay, let me draw it here again. So this is our origin, this is our a by 2, and this is a, t1 and t2, and total time is our t, which is equal to t1 plus t2. So it means when time is equal to t1 plus t2, particle is at extreme position a. So once again, substituting in the equation, and equation is x is equal to a sine omega t. So our x is now equal to a, so this is equal to a sine of omega, and t is our t1 plus t2. A and a cancels out, so we get this is sine of omega t1 plus t2 is equal to 1, and this will be obviously coming as inverse of 1, and from here we get omega t1 plus t2 is equal to pi by 2, or we can say t1 plus t2 is equal to pi by 2 upon omega. We already found out our t1, so from here we can calculate that our t2 is equal to pi upon 2 omega minus t1 is equal to pi upon 2 omega, and t1 was our pi upon 6 omega. So we got that t2 is equal to pi upon 3 omega. So once again, finding the ratio t2 by t1. t2 by t1 gives us pi upon 3 omega, pi upon 6 omega is equal to 2. We can say that t2 is equal to twice of t1, and from here also we can say that t2 is greater than t1. So it means option A is our correct option. Okay. Option A is our correct option. Option A is correct. So this completes the question. Thank you.